Alright, we're going to do question number 3 from the 2007 Calc BC exam. This is technically a calculator question, but I'm going to do the whole thing pretty much without a calculator because you don't really need one, and I just can't imagine that this would still be a calculator question. So you're given the figures, or a figure rather, and you're given the curves r equals 2 and r equals 3 plus 2 cosine theta. You're also told that they intersect at 2 pi over 3 and at 4 pi over 3. So what I'm going to do is add in some radial lines there. And if you look at it, we have two regions. One that's bounded just by the circle, which is r equals 2, and those radial lines. And one that's bounded just by the limison and those radial lines. So what I'm going to do is break it up into two different integrals to find this area. So the first one, we'll use this region, and then I'm going to double it because there's two of them. So that's the region we're going to find first. So there's two of those. Every polar integral, we put the 1/2, and then it's going to be the integral from 0 to 2 pi over 3. And then it's 2, and we're squaring it. So remember, polar integrals are 1/2 the integral from a to b of r squared d theta. So d theta. The next thing we're going to do is that other little region that you can see. So right there, there's two of those. So the 1/2 because it's a polar integral. And then from 2 pi over 3 to pi, and it's the other curve. And then square it, and then d theta. We have to add these together. And now this is the part that you would definitely use a calculator on. Just add those two together, get your answer, and you're done. So that's how we find that area. A lot of people are afraid of polar areas, but you really shouldn't be. The next question is we're told that something's moving along the curve. So dr dt, so the rate at which it changes with respect to time, the radius changes with respect to time, is equal to dr d theta. They're just telling us that to make the calculation doable, I guess. And we know that we're moving along r equals 3 plus 2 cosine theta. So what we're asked to find is the value of dr dt at pi over 3, and then we want to interpret it. So I'm going to do this by hand, even though it's a calculator question. So when this was given, I would have done the entire thing on my calculator. So take the derivative, then the values at pi over 3, so let's evaluate that at pi over 3. You got to know your unit circle a little bit here, or at least your trig values, to get that the final answer is negative radical 3. So dr dt is negative radical 3 when theta equals pi over 3. So it's the rate of change of the radius with respect to time, which means that the radius is decreasing. But I'm never really sure if I answered the question by just saying that the radius is decreasing. I feel like I did. But in this case, I'm going to say that the particle is getting closer to the origin, because that's literally what it's doing. So we'll go with that. Let me just show you a little bit on the picture here. So what's happening is that's my estimate of pi over 3, which actually is a little too high, I think. And that's where we're starting. And what happens is we move along the curve like that. And I'm going to put in some radial lines, and you can see. So you know, the first one, it basically you can see that those radial lines are getting shorter, which means that dr dt is less than 0 because it's decreasing. All right, now for part C, you need to walk in knowing that for polar x equals r cosine theta, y equals r sine theta. That's how you can convert from polar to parametric, and then if you have it in parametrics, you can find dy dx and all that stuff. But anyway, for this question, we really just need to find dy dt, which we're told is equal to dy d theta. So we use y equals r sine theta. Now I'm going to take the derivative by hand. Again, when this was given, it was calculator. I would have done the entire thing on my calculator and just had my calculator evaluate the numerical derivative. But instead, here I'm using the product rule. First derivative second plus second derivative first. Now I need to evaluate it, which isn't such a bad evaluation. On a calculator, this would be a joke, because it would just do all of the work for us, but instead you can watch me. Simplify this. Finally, I get dy d theta, which is the same as dy dt, is 1/2. Now I need to interpret this. So dy dt is greater than 0, and that means the y-coordinate is increasing, and the particle is it's moving up. So let's take a look really briefly. So what I'm going to do is on this picture, I'm going to show you where dy dt is. Well, I'm going to move around the limison. So on this interval, dy dt would be greater than 0 because you're moving up. Now I'm going to use this other color here for when dy dt is less than 0. So as I keep moving, now y is decreasing. It's no longer getting bigger. It's now getting smaller. So on this whole interval here, it's decreasing. Y is decreasing, that is. And then it changes to increasing again. And then it changed from increasing to decreasing. There must have been times when it was 0, and those are the times when it was 0. So that's this question. It's a polar question. There's no reason not to get all of the points on a polar question. Just takes a little bit of practice and not being afraid of them. But I hope you found this helpful, and good luck.